Hello and a very good day. So today our Group 3, will be presenting our Renewable Energy 1 project entitled The Design of a Solar Water Heating System for a Hospital in Ipoh. So our team consists of 5 group members: Aireen, Redza, Nabilah, Jecozale, and also Daniel.
The design of a solar water heating system for a hospital in Ipoh involves a meticulous approach to harnessing solar energy to meet the substantial hot water demands of a healthcare facility. This system will include strategically positioned solar collectors on the hospital's rooftop to maximize solar exposure and efficiency. The collected solar energy will be converted into heat and transferred to a working fluid, which will then circulate through an integrated piping system to a well-insulated storage tank. The stored hot water in storage tank then will be supplied to the hospital for its continuous need for sanitation, laundry, and patient care. The system will be designed to ensure a reliable and consistent hot water supply while significantly reducing energy consumption and operational costs. This initiative aligns with sustainable practices, supporting hospitals' commitment to environmental responsibility and energy efficiency. Solar water heater is an effective way to generate hot water using solar. They are categorized into two types, which is active systems, which utilize circulating pumps and controls, while passive systems, which operate without them. For active solar water heating system, which are categorized into two types, which is direct circulation system, or known as open loop system, and also indirect circulation system, or known as closed system. Direct circulation system use pumps to move household water through solar collectors and into the home, making them suitable for areas with mild climates where freezing is rare. In contrast, indirect circulation system, or known as closed loop system, use pumps to circulate a non-freezing heat transfer fluid through the collector and a heat exchanger to heat the household water, which is ideal for regions with frequent freezing temperatures. For passive solar water heating system, there are two main types of passive system, which is integral collector storage, which consists of a storage tank covered with a transparent material to allow solar heating of the water. And also another one is thermosiphon system, where water is heated in a rooftop collector and flows through the plumbing when a hot water faucet is opened. In this project, the direct open loop water heating system is chosen to be designed for hospital necessities. This system, where the water that will be used in the hospital will be circulated directly through the solar collectors, which then will be heated by the sun. This design is straightforward and involves fewer components, making it easier to install and maintain. And since the water is heated directly in the collectors, it results in higher efficiency and lower installation, which also maintenance costs. Since the disadvantage of this system is not suitable for climates with freezing temperatures, as the water can freeze and causes damage to this system, hence it is suitable to be designed in Malaysia as the weather climate is hot. Most solar water heaters need a well-insulated storage tank with extra outlets and inlets connected to the solar collector. In two tank systems, the solar heater preheats the water before it enters a conventional heater, while one tank systems combine the backup heater and solar storage in one tank. There are three main types of residential solar collectors, which are flat plate collectors, integral collector storage system, and also evacuated tube collector. For a flat plate collector, which is insulated, weatherproof boxes that contains a dark absorber plate under one or more glass or plastic, which is polymer covers, while unglazed flat plate collectors, typically used for solar pool heating, have a dark absorber plate made of metal or polymer without a cover or enclosure. For the integral collector storage system, which also known as ICS or batch system, they feature one or more black tanks or tubes in an insulated glazed box. Cold water first passes through the solar collector, which preheats the water. The water then continues on the conventional backup water heater, providing a reliable source of hot water. They should be installed only in mild freeze climates because the outdoor pipes could freeze in severe cold weather. For the last type of solar collectors, which is evacuated tube, they feature parallel rows of transparent glass tubes. Each tube contains a glass outer tube and metal absorber tube attached to a fin. The fin's coating absorbs solar energy but inhibits radiative heat loss. These collectors are used more frequently for United States commercial applications. In this project, the flat plate collector is chosen to be designed due to their versatility, cost effectiveness, and reliable performance. This project of solar water heating system has three objectives. The first objective is to design a solar water heating system in providing hot water to a hospital in Ipoh. The second objective is to conduct a comprehensive cost and economic analysis for solar water heating system to assess its financial feasibility. And the last objective is to identify the potential environmental impact associated with solar water heating system that will be designed. There are three scope of work in this study, which is the first one employing SolidWorks software to design the solar plate collector for open loop solar water heating system. The selection of materials plays a crucial role in this process, requiring careful attention to thermal properties such as thermal conductivity and radiant heat transfer coefficients. To accurately size the solar water collector, which is the system primary component, which the data on the hospital annual hot water consumption is gathered through a literature review. This ensures that the system is tailored to meet the specific needs of the hospital in Ipoh effectively. The second scope of work, which is to perform cost and economic analysis for the thorough examination of energy cost and payback period. After completing the design and necessary calculations, a cost and economic analysis will be performed to evaluate the financial viability of implementing the solar water heating system. This analysis include an examination of energy costs and the calculation of the payback period, which indicates the time required for the project to recover its initial investment. A shorter payback period is advantageous as it reflects a faster return on the initial expenditure. The last scope of work of this project is to perform environmental analysis. So the solar water heating system must operate under various environmental conditions, making an environmental analysis essential for ensuring optimal performance. So gaining insights into how these environmental elements affect the solar water heating system is critical for designing solutions that can function efficiently and sustainably over time.
Next, moving on to the literature review section. So the first literature review done was on the hospital capacity. So here we have selected an example of KPJ Ipoh Specialist Hospital. So according to KPJ Health Official 2024, KPJ Ipoh now has a capacity of 267 beds, indicating that they could admit around 267 patients in one time. Next, we also identified that every hospital resident requires approximately 160 liters of water daily. This is cited from Eltham, MFG 2022. And finally, according to Gaia 2016, discharge temperature, which is the required temperature of hot water, should not be lower than 54.4 degrees Celsius, in which, in this case, in this project, we target to have the discharge temperature water more than 80 or equals to 80 degrees Celsius.
Next is the local solar irradiance of Ipoh. According to the International Renewable Energy Agency (IRENA), Ipoh has a global horizontal irradiance or GHI average of 4.9 kilowatt-hours per square meter daily, or about 1,800 kilowatt-hours per square meter yearly. And now we move on to the flat plate collector. The flat plate collector has several advantages over other solar thermal systems. It is simple, cost-effective, and reliable. Flat plate collectors are also able to capture both direct and diffuse solar radiation. Thus, it is very efficient.
Now, moving on to the process flowchart. So, this project was started by initializing the location and hospital consumption of hot water. After identifying and initializing required data, next comes the process of identification and concept generation for the solar water heater system. And after that, we could plan on the design calculations and also proof of concept. After that, if the design concept parameters are approved by the team members, we could then proceed with the designing step. And this will indicate the finalized solar water heater system. And the flowchart ends. So this flowchart, the significance is crucial for the ideation planning of solar water heater, organizing the project flow, and also ensuring a successful project implementation. Now, for the Gantt chart and milestone, here we have highlighted five main phases of the project. So the first phase is project literature research, phase 2 is generating conceptual design, phase 3 is designing solar water heater, phase 4 evaluation analysis of design, and finally phase 5, which is the documentation and presentation phase. So throughout the semester, we have consumed around 12 weeks in order to complete the project. Next, for the project activities, In this project, we have highlighted two main activities, which is first the calculation part and second the designing part. So for the calculation part, we have two main equations that we have used. So given the specification and also initialization parameters, we first have to find the heat energy transfer, and afterwards we use the second formula to obtain the required number of panels in order to meet the project outcome, which is having a water discharge of 80 degrees Celsius. And afterwards, after finalizing the desired parameters, next comes the designing part, in which here we have utilized SolidWorks simulation for us to design the solar water heater system. Before proceeding to the calculation section, first we have to identify the assumptions and also given specifications for this project. So first, we assume the ambient temperature in Malaysia is 26 degrees Celsius. And second, we also assume that the supply flow into the collector has a temperature of around 30 degrees Celsius. And according to our literature survey, we have identified that the average solar radiation in Malaysia is around 4.9 kilowatt hour per meter squared each day. And since we have given the specification of sunshine hours is 7 hours, therefore we can calculate the average solar irradiation in Malaysia is around 700 watt per meter squared. Next, for the given specifications, we have identified the required discharge temperature of water, which is T out, should be at least 80 degrees Celsius. We also been given the maximum capacity, which is 2.5 meter cube. And since one day is equals to 24 hours, therefore we could find the water flow rate, which is finally we could obtain 2.89 times 10 to the power of negative 5 meter cube per second. Now we could proceed for the calculation part of solar water heater system. So previously we have calculated the volume flow rate is around 2.89 times 10 to the power of negative 5 meter cube per second. Plugging in that value into the stated equation that we have here, therefore we could obtain the overall heat energy transfer, which is the Q value, will be around 6076.39 watt. After that, we substitute the obtained Q value into the main equation, and hence we could obtain the total solar plates needed, which is around 6 plates needed for this project.
So I'll be presenting on the design and components of our solar water heater. As you can see in this 3D model, the main parts include a solar collector panel with a glazing cover, a storage tank to store the water, a piping system with inlets and outlet headers and riser tubes, and a supporting frame. This design efficiently captures solar energy to heat out water. These are the different views of the heater. The top view shows the overall layout, the front view displays the collector and tank arrangement, and the side view illustrates the incline of the collector for optimal sun exposure, making it sustainable solutions for solar water heating system used in Ipoh Hospital. This is the detailed engineering drawings with all the precision measurements crucial for manufacturing and installation. Now I will explore the materials used for each component carefully with their justifications, with a special focus on the design factors and key components. I will draw attention to a few parts which affects the efficiency of our solar water heater. First, the glass cover is made of low iron tempered glass for high solar transmittance and durability. Second, the absorber plates uses black copper coated for excellent thermal conductivity and absorption. Third, the glass wool insulation provides high temperature resistance and low thermal conductivity. So these materials are carefully chosen to maximize the efficiency, durability, and performance of the solar water heating system for hospital in Ipoh. This solar water heater design efficiently captures solar energy, heats out the water, and stores it for use, providing an eco-friendly alternative to traditional water heating method. These carefully selected materials contribute to the overall efficiency and longevity of the solar water heater. These parameters ensure optimal performance in capturing and retaining solar heat for water heating purpose. For the benchmarking, we have an example of a commercial solar water heater unit, the Gorman model. This gives us a real-world perspective on how these systems look like when they are installed. When benchmarking with the industrial solar water heater systems, we compare a few factors such as the efficiency of heat capture and transfer, second, the storage capacity, third, the durability of materials, and lastly, the overall system performance under various environmental conditions. By understanding these components and their interactions, we can optimize solar water heater designs for hospital in Ipoh, ensuring maximum energy efficiency and reliability.
On to discussion. First, we will talk about the environmental effect and impact. Firstly, the usage of solar water heater will reduce greenhouse gases. This reduces reliance on fossil fuels, cutting carbon dioxide emissions significantly. Next, there's also an air quality improvement, which decreases emissions of SO2, nitrous oxides, and particulate matter, leading to better air quality. Other than that, SWH also uh, allows resource conservation. It preserves non-renewable energy resources, thus reducing environmental impact. And lastly, the SWH has minimal land use. The rooftop insulation minimizes land use and habitat disruption. Next, economic analysis. For the cost of the total energy used, we can get that by multiplying the wattage of the solar plates with the hours of sunshine per day, which is roughly 7 hours, which results to around 159.254 kilowatt hour per day. And as said by DNB, the cost for electricity is 21.8 cents per kilowatt hour. Thus, we can use these values to calculate the equivalent cost of energy if the water is heated by electricity instead of the solar water heater. Thus, the equivalent is around 2,600 ringgit. For the initial investment, as mentioned in the literature review, the cost associated with the purchasing, assembling, and all other related costs for the hospital in Ipoh is estimated to be 0.56 ringgit or 56 cents per kilowatt hour produced. Thus, from this, we can calculate that the cost of installment of the solar water heater is around 32,000 ringgit. And for the total annual cash flow, we take into consider the annual maintenance cost, which is from literature around 320 ringgit every 3 years. We average this for every year to result in the annual cash flow of 12,565 ringgit and 86 cents per year. Continuing on, assuming that the solar water heater is installed in December, that means the hospital does not need to pay electric bills starting from year 1 onwards. Hence, we can get the discounted cash flow tables as shown, where the initial investment is around 32,000 ringgit with additional cash flow of 12,000 ringgit every year. As you can see, the payback period is only 2.76 years, meaning that after 2.76 years, the hospital will receive positive cash flow. Thus, from these results, we can conclude these 4 things. The annual inflation rate of 3.38% makes solar power shield against rising electricity costs. Secondly, the financial benefits of using solar water heater shows from the net cash flow evaluation. It shows that the substantial savings after initial cost recovery, meaning that after the 3rd year, the hospital will gain constant cash flow of 2,000 ringgit present value every year. Next, the solar energy investment is also cost effective and sustainable. And in the long term, there will be continual financial benefits beyond the break-even point. So in conclusion, the installation of solar water heater is economically feasible. Finally, we will discuss on the social sustainability. First, the solar water heater will cause improved healthcare services. The reliable hot water supply enhances patient care, sanitation, and hygiene. Secondly, it will affect by having the resource to be reallocated. Thus, savings can be done on energy bills, which can be directed to patient care and staff development instead of the electricity. Next, in terms of community engagement, it fosters community pride and trust, encouraging other institutions to adopt sustainable practices, providing a chain reaction. And lastly, the solar water heater also creates jobs. It creates local job opportunities in system design, installation, and maintenance.
In conclusion, the selected open-loop system utilizing flat plate collectors is particularly suited to the Malaysian climate, ensuring higher efficiency and lower maintenance costs. The detailed calculation indicate that the system can reliably provide the necessary of 43,000 liters of hot water daily at the required discharge temperature of zero point 0.4 degrees Celsius, maintaining hospital safety and compliance with health regulations. Economically concluded, the system proves to be a sound and a great investment. With an initial cost of Rm 8,000 and annual savings of Rm 3,000 on electricity bills, the payback period is calculated to be approximately 3 years. This quick return on investment, combined with the long term savings and protection against rising energy costs, underscores the financial feasibility of the project. From an environmental perspective, the solar water heating system significantly reduces greenhouse gas emissions, aligning with global efforts to mitigate climate change and promoting a cleaner environment. The reduction in pollutants such as sulfur dioxide and nitrogen oxides also contribute to improved air quality, benefiting public health. In summary, the proposed solar water heating system not only meets the operational requirements of the hospital, but also supports its commitment to sustainability and energy efficiency. By transitioning to solar power, the hospital sets a benchmark for environmentally responsible healthcare practices, ensuring a sustainable and cost effective solution for its hot water needs.